In this video, we're going to review U-Substitution to help us find antiderivatives and integrals. So our only real tool for taking integrals is the reverse power rule and just memorized trigonometric antiderivatives. But if we're trying to take the antiderivative of more complicated things, we're going to have to do substitution. And so here's a general strategy. You can kind of pause this and write it down. But the basic idea is we try to find something that its derivative is also in the problem. And we use that in order to kind of simplify the problem we're looking at. All right, but go ahead and pause the video if you want to write down all these steps. We're just going to do them in the examples. All right, so here's a complicated problem. If we had this problem without substitution, we'd have to multiply all this all out and distribute this in. But with a fifth power here, that's way too much work. So when you do substitution, and again, substitution is generally the u is going to be the thing that's inside of something else. So here u is going to be 1 plus 2x cubed. Take the derivative, and even though we're trying to do antiderivatives, we actually do a derivative in this process. It's going to be 6x squared dx. Divide du over 6x squared is dx. All right, so this is all the side work we have to do, and now we can go to our problem over here. X squared doesn't change, but 1 plus 2x cubed, that's what we called u, so now this is u to the fifth. Dx, we know that's du over 6x squared. And again, you know you've done this right if the x's cancel out and you're only left with numbers in u. In this case, you get the 1/6, which I'll just write at the front, u to the fifth du. All right, the other thing, we have these bounds. Because we're switching from x to u, we can't put the 0 and 1 here, but we know x is 0. So if x is 0, u is 1 plus 2 times 0 cubed, right? It's just using this equation between u and x, and that's 1. So if x is 0, u is 1. And if x is 1, it's 3. U is 3. All right, so now I can change my bound to be about u instead. And now I can finish doing the problem. So the 1/6 is just going to kind of hang out. The antiderivative of u to the fifth is u to the sixth over 6, evaluated from 1 to 3. Which would be, again, the 1/6 is just going to hang out on the outside as we do 3 to the sixth over 6 minus 1 to the sixth over 6. And 3 to the 6th is some big number. Actually, it's not that big. Let's just put it in. 3 raised to the 6th. 729. All right. And we get 728 over 36, which I'm guessing simplifies a little bit. What's it simplify to? 182 over 9. Okay. All right, so that's u substitution with bounds. You pick your u to be the thing inside. You use that to simplify your expression. The only thing that's different when you have bounds is you change your bounds to be about u. And you don't have to switch back to x's at any point. You just get down to your answer using the smaller stuff with u. All right, this problem, integral of sine of x over cosine cubed of x. This isn't an obvious problem where you're going to use substitution because normally we see parentheses, but one thing to always remember is that whenever you have those powers of our trig functions, they're actually just shorthand for it looking like that. Right, this 3 is actually just it telling us it's cubed. So here it might be more obvious now to make u equal to cosine of x. All right, du is negative sine of x dx. And du over negative sine of x is dx. All right, so now my problem becomes sine of x over u cubed, and then dx is du over negative sine of x. Again, you know you've done it right if all the x stuff goes away. Oops. All right, this negative is going to hang out. We still have u cubed du. You can bring the negative to the front if you want. I'm going to rewrite this as a power of u So then I can do the reverse power rule. Oops, I don't need the integral anymore. Negative, you add 1 to the exponent, so negative 3 plus 1 is negative 2, divided by the new exponent. The negatives cancel. And then I remember that u is actually cosine of x. And chances are you would see it written like this. All right, because that negative 2 exponent moves back to the bottom. All right, but this is just recognizing this happens a lot where, again, the shortcut kind of hides the fact this is a chain rule. You don't really see these parentheses. Rewriting like this will kind of help you identify what u should be, but for them from there, everything is the same. Here's another example. Again, looks complicated. There's x's and cosine mixed together and you're trying to do an antiderivative. So really our only option is to do U-substitution. In this case, u is the thing on the inside of the parentheses. Identify u and take derivatives. All right. X squared hasn't changed, but x cubed is u. And dx is du over 3x squared. Again, the x's cancel out, so I know I picked the right u. I have this 3, I'll just write at the front. And it's a 3 on the bottom, that's why it's a 1/3. Cosine of u du. Take the antiderivative of cosine, that is sine. And then replace u. This is kind of the difficulty I would be expecting of a U-substitution problem on the AP test. Not super complicated, but still having to know a lot of little parts to get the right answer at the end. And here's one for you to try on your own. Again, notation-wise, I think about what your u should be at the start. I'll share the answer in 3, 2, 1. And here you can see the answer here on the right. Again, this notation is just hiding the fact that this is actually sine to the 7th, so our u is going to be this inside sine. I figure out du and plug it in. The cosines cancel, add 1 to the exponent, divide, replace u with sine. That's a quick summary. Simplify with substitution before taking the antiderivative, so you're picking that u to be the thing inside some parentheses, taking its derivative and plugging it all, and then always look for the thing inside of something else. That's going to be your hint for what u is.